Welcome to the new private pesticide applicator training. This is Module 7, Application, Calibration, and Calculations. If you haven't done the calculations worksheet yet, you may want to stop here and make sure you complete that because we're going to go through those calculations at the end of this module. This module really is about applying the right amount. What are the factors you have to be concerned with to make sure that you do? Applying the right amount of pesticide is important for effective control. If you apply too little or underdose, that can lead to poor control, and it also can be an unnecessary expense if repeat applications become necessary. Underdosing also can contribute to the development of pesticide resistance because the pests are more likely to survive and pass on resistance genes if the pesticide rates are suboptimal. Overdosing or applying more than the label allows is illegal. That's the number one reason not to do this. But it also can injure your crop. It can be an unnecessary expense and be problematic for the environment. Be sure you pay attention not only to the label maximum application rates, but also the total amount that you are allowed to use per season or per year. There's a number of factors that affect how accurate you are with your rates. We're going to talk about these throughout this presentation, but to kind of summarize, sprayer calibration is very important, and also that your sprayer operating parameters, your sprayer setup is correct. So things like the driving speed, the spray pressure, of course those are very much involved in sprayer calibration, the boom height, your nozzle overlap on the boom, the type of nozzle you've chosen, and the condition of wear of those nozzles. Also, you need to be able to correctly calculate how much to add to the tank, and we're going to go through calculations to help you with that. You have to accurately measure the chemicals and follow appropriate mixing and loading procedures, for example, tank mix order. Calibration is critical. Calibration is the procedure that ensures that your equipment delivers the desired amount of pesticide uniformly over the treatment area. In a calibration, the equipment is operated over a test area of known size, and how long it takes to cover that test area is determined. Next, the sprayer is operated for that same length of time, and the sprayer output is collected and measured. With this information from these two steps, the spray volume in gallons per acre can be calculated. You must adjust your equipment as needed and repeat these steps until the correct output is achieved. Individual nozzle output can be assessed during a calibration to ensure they are all delivering a uniform amount. During calibration, you measure the output from each individual nozzle. If a particular nozzle diverges more than 10% from the average nozzle output, it should be replaced. Typically what happens is that nozzles become worn with use, and you will observe a higher output from the worn nozzles. Application spray volume is important, and we're going to talk about that. Typically, farmers will have a target spray volume in mind before they begin their calibration. For example, you want to use 8 gallons per acre. And the process of calibration is going to involve fine-tuning your equipment to achieve that desired output. Now, you may have a target in mind for practical reasons. For example, you don't want to have to carry a lot of water to the field. But it's also important to follow the pesticide product labels and look at the ranges that they recommend for your spray volume. Looking at the example on this page of Weed Buster, this particular example comes from a contact herbicide with a relatively high gallons per acre that is necessary to ensure adequate coverage. And it says apply Weed Buster 2L in a minimum of 15 gallons of water per acre. Increase to 20 gallons of water per acre if there is a dense weed canopy. There's other considerations for deciding what gallons per acre to use. So the type of pesticide and the spray coverage that you need. We already talked about a contact herbicide. Generally, these are going to require higher gallons per acre and better coverage than a systemic herbicide. But also, fungicides and insecticides may require higher coverage and higher gallons per acre as well. One of the reasons is to get adequate penetration into the canopy of your crop. Spray volume is also important to help reduce drift. Both spray droplet size and higher gallons per acre will help you reduce drift. During a calibration, it's likely you're going to have to adjust your sprayer settings and driving speed to achieve the targeted spray volume. When you alter your driving speed, when you increase your driving speed, your GPA will go down. You're covering the ground more quickly and you're not applying as much volume. With operating pressure, when you increase the operating pressure, the GPA is also going to go up. With nozzle size, when you increase your nozzle size, naturally your gallons per acre are also going to go up with the larger aperture size. Don't be surprised if you see questions like this on your core exam. Of course, if you have a rate controller on your sprayer, these are designed to hold your gallons per acre or your spray volume steady. So as you, for example, increase your driving speed, it's going to drop your spray pressure, or in this way keep your gallons per acre constant. Your choice of nozzles is going to affect your flow rate, your spray pattern, and your droplet size. Nozzles can be characterized by the spray angle. Typically 80-degree angles and 110-degree angles are used in agriculture. The type of pattern that they provide, for example, a flat fan or a hollow cone. All nozzles are going to have a operating pressure range, and it's very important that you don't use the nozzles outside of their operating pressure ranges. All nozzle outputs are rated at 40 psi, but of course their output or their flow is going to depend upon your actual operating pressure. Finally, droplet size categories. This is an important concept. Many pesticide labels now specify the droplet size category that you need to be using. So this means you must select the nozzle that produces that size droplets under your equipment's operating pressure, because your actual droplet size is going to depend on not only the nozzle aperture but your operating pressure. So you can either talk this over with your dealer, or you can use your manufacturer's nozzle charts to determine what the droplet size category will ultimately be with your nozzle at the operating pressure that you intend to use. Now, I already mentioned that an important part of calibration is to determine if the delivery from the individual nozzles is uniform. This slide gives you an example problem like you might actually see on your core exam. So what it's telling you is that during a trial calibration, the average output that was collected from each sprayer nozzle was 9.5 fluid ounces. And then the actual outputs from each of the nozzles is shown on the slide. The question that you might consider is which nozzle of any of these should be replaced. So this slide shows you how to solve that problem. So remember that any nozzle having an output that is greater than 10% plus or minus the average needs to be replaced. So in this case, 10% of the average of all of these values is 0.95 fluid ounces. And plus or minus 10% on the high side is 10.45 fluid ounces, and on the low side is 8.55 fluid ounces. So anything that does not fall in that range needs to be replaced. So when you look at the nozzles, you can see that the one in the middle, the 10.6 ounces, fluid ounces, falls outside that range. Therefore, that nozzle should be replaced. Now let's look at a pesticide calculation example, similar to what you may see on your pesticide exam. Now, this question asks you how much herbicide is needed to mix a full tank given the following parameters. A 100-gallon tank, your intended gallons per acre is 15, and the recommendation is to use 2 pints of the product per acre. The first step in this problem is to determine how much area, how many acres you're going to be able to treat within a full tank, because we want to mix a full tank. And the way you do that is divide your tank capacity by your GPA. So 100 gallons per acre divided by 15 GPA, you will be able to treat 6.7 acres with a full tank. Now this problem actually becomes much easier. You know that you're going to be able to treat 6.7 acres with that tank full, and you know your product rate is 2 pints of an acre, so you simply multiply those two, and that tells you that you will need to use 13.4 pints of product to mix a full tank. Now, normally we're going to have to do conversions in real life and also in our pesticide exam. Typically, we don't buy products in pints. We oftentimes buy them in gallon containers. So, assuming the product comes in gallon containers, you have to be able to do a conversion. You will need to make liquid conversions between pints, quarts, fluid ounces, and gallons on your exams. You need to know that there's 8 pints per gallon. So 13 pints, there's 8 pints in a gallon, so you divide the 13 by 8, and the answer is 1.67 gallons per tank. So if you had to purchase this product in gallon-sized containers, you would need to get 2. Now, understanding pesticide formulations may be required for some types of pesticide calculations, and we're going to see how this works in the next few slides. All pesticide products must disclose the active ingredient or toxicant. So your dry formulations, sometimes right in the formulation name, it will tell you what the percent active ingredient is by weight. For example, a 75 wettable powder formulation contains 75% active ingredient by weight. Some liquid formulations, the name will give you the pounds of active ingredient per gallon of that product. For example, a 2E or 2 emulsifiable concentrate. What the 2 means is 2 pounds active ingredient per gallon of that product. We've already covered formulations in an earlier module, but just to review what some of these mean, dry formulations include wettable powders or WP, water dispersible granule, sometimes WDG or WG, granules G, dusts D, pellets P. Common liquid formulations include the emulsifiable concentrates or EC, solutions S, sometimes AS, aqueous solution, and flowables, which can appear as L or F. Here's some example formulations, some more. Atrazine 4L, so the 4L means 4 pounds active ingredient per gallon in a liquid. And the Captain 80 WDG means 80% active ingredient by dry weight in a water dispersible granule formulation. Okay, let's do a pesticide calculation where we actually have to convert pounds active ingredient to how much product we need. This asks you how many pounds of 80% wettable power herbicide do you need to treat 120 acres if the recommended rate is 2 pounds active ingredient per acre. So once again, that 80 WP means 80% active ingredient by weight. Now there's a tip for solving active ingredient problems. You can see that down about the middle of the slide. What you want to do is divide the amount you need in active ingredient, remember that's 2 pounds active ingredient, by the amount in the product. Okay, so the way that we solve this problem is 2 pounds AI per acre, that's the amount we need or want, divided by the amount in the product, which is 80%. 2 divided by 80%, the answer is 2.5 pounds product per acre. Now, in this problem, we were going to treat 120 acres. Now we know the product rate, of course, and we multiply that by 120 acres. 2.5 pounds per acre times 120 acres is 300 pounds per product. Now we'll work on some more math problems when we go over the calculations worksheet at the end of this presentation. Next, I'd like to talk about is how to avoid tank mixing problems. Number one, always follow the proper tank mixing order given by the label. For example, a typical mixing order that a label may instruct you would be to add half of the amount of water or liquid fertilizer first, followed by wettable powders, followed by emulsifiable concentrates, and then finally the remainder of the water. Of course, agitating the whole time you do this. But the take-home message is that read the label. If you are working with pesticides of unknown compatibility, always do a compatibility test, and we'll talk about that in the next slide. Some of the things that can go wrong with incompatible mixes, well, basically creating a lot of residue in the tank, in the application equipment, the mixture not properly uniform, and your pesticide application will be ineffective. The other type of tank mixing problem to avoid relates to your water quality. Both water pH and hard water, or the presence of hard water cations, can affect the stability of your tank mix. So this is also, you need to read the labels. Some of the ways that you can get around this is to use a buffering agent or a water conditioner in the case of the hard water ions. This slide goes over how to actually do a compatibility test. Basically, you're going to mix up a small amount of the solution in the same proportions that you would use in the tank mix. So I'm not going to read through all this, but this is how you would go about doing a compatibility test. Obviously, the compatible mixtures are going to be smooth and uniform. The incompatible mixtures will have clumping and separation, and that's what you want to avoid. I mentioned tank agitation. Agitation is critical when tank mixing, and to keep insoluble mixtures from settling inside the tank. So especially the wettable powders, the water dispersible granules, the flowable products, these will tend to settle out in agitation not only during mixing but throughout your application is critical. Here again, poor tank agitation can lead to products settling out and even a uneven application. So why would it lead to an uneven application? It's because if you're pulling out the dilute solution, you're getting an under application, but if you're pulling out from where it's a sludge at the bottom of the tank, you could be putting on very high amounts, and this could lead to phytotoxicity and clogging of your equipment, etc., etc. Sprayer clean out is important. If you fail to properly clean out your sprayers between, say, a herbicide or an insecticide application, you can most definitely wind up with crop injury, with oftentimes seeing the greatest damage at the ends of the boom where the oil spray solution has collected. And that's in fact what the slide is showing. This was something like a 90-foot boom, and at the top of the slide you're seeing what was the ends of the boom and a great deal of injury. What's very important with sprayer cleanout is, one, to follow the pesticide label explicitly, what they tell you to do. And whenever you're using a commercial tank cleanout product, make sure you carefully follow the manufacturer's instructions. At this point, if you haven't completed the calculations worksheet, I suggest you stop here and come back to this part later. So we'll now go through the answers to the calculation worksheet problems. Question number 1 is, how much weed kill herbicide is needed to treat 120 acres if the labeled rate of your pesticide is 8 fluid ounces per acre? This problem is fairly simple. You want to multiply the pesticide product rate in fluid ounces per acre by the total area in acres. So 8 fluid ounces per acres times 120 acres is 960 fluid ounces. Now, since we typically cannot buy product in ounces, we may need for this problem to convert to gallons. And just a tip for the ODA exam, you may need to know how to convert between fluid ounces, pints, quarts, and gallons. So you need to know that there's 128 fluid ounces, 8 pints, and 4 quarts to a gallon. So to convert 960 fluid ounces, you divide by 128 fluid ounces per gallon, and the answer is 7.5 gallons. In problem 2, you're asked how much water you will need to take to the field to spray 225 acres if your sprayer is calibrated to apply 12 GPA. This problem is another simple multiplication problem. If you're putting out 12 gallons per acre and you're spraying 225 acres, you multiply those two to get 2,700 gallons. Question 3, calculate how much product is needed to mix a full tank. The labeled rate is 0.25 pounds of product per acre, and your tank holds 1,000 gallons. Your spray volume is 10 GPA. Step 1 is going to determine how many acres you can spray with a full tank based on that GPA. So what you do is divide your tank capacity by the gallons per acre. 1,000-gallon tank divided by 10, you can treat 100 acres with a full tank. Now you will multiply your product rate in pounds per acre by the number of acres you can treat with a full tank. So 0.25 pounds product per acre times 100 acres, the answer is 25 pounds of product will be needed to mix a full tank. Question number 4 is similar to the last problem, except that the labeled rates are given in pounds of active ingredient per acre. In order to convert that to product, you will have to know how much of the active ingredient is in the product. So what it tells you is that it is a 4-EC herbicide, and you have to know in order to solve this problem that that means 4 pounds product per gallon. So now let's solve this problem. Step 1 is to convert your rate in active ingredient per acre to how much product you need per acre. And the way that you do that is to divide the amount needed in active ingredient by the amount in the product. So step 1, you want 1 pound active ingredient per acre. You know that your product formulation contains 4 pounds active ingredient per gallon. So you divide those two and you come up with 1/4 of a gallon of product per acre is what you need. So now we have made that conversion from active ingredient to product. The next step is similar to the preceding problem. You're going to determine how many acres it can be sprayed with a full tank. So 600 gallons is your tank capacity, and your GPA is 12, so you divide 600 by 12. With a full tank, you will be treating 50 acres per tank. In the last step of this problem, you will multiply the product rate, now in gallons per acre, by the number of acres you can treat with a full tank. So 0.25 gallons of your product per acre times 50 acres, and your answer is you will add 12.5 gallons of this product to fill the tank. Question 5. A herbicide label recommends adding a wetting agent at 0.5% by volume. How much wetting agent is needed for 75 gallons of tank mix? Give the answer in fluid ounces. These percent by volume problems are fairly easy. All you have to do is multiply the tank volume by the percentage of wetting agent that you want to add, or whatever the product might be. So you multiply the 75 gallons by 0.5%. Now, when you make this calculation, your answer is 0.375 gallons. To convert the gallons to fluid ounces, certainly it's a lot easier to measure in fluid ounces than it is 0.375 gallon. You have to know that there's 128 fluid ounces in every gallon, so you multiply that by 0.375, and your final answer is 48 fluid ounces. This is the end of Module 7. You now may take the quiz in your core study guide on pages 46 through 51.